Hello, a very good evening to you all, my students, and also those who are watching this live session. Today, I am here during this first session to have a quick run through integration 1. Integration 1 means indefinite integrals, and you know, indefinite integrals is the backbone of integral calculus. It's the heart and soul of integral calculus, and without this indefinite integral you cannot do any question from differential equation. So you can have a quick revision with the differential equations too. Alright, so straight away we move on to the quick revision. Well, this is indefinite integrals. First of all, definition and all I am not at all going through, but anyway, you know integral of 1 by x dx. What's integral of 1 by x dx? This is equal to logarithm of x plus c. So this 1 by x is called the integrand. This log x, the answer log x, that is called the antiderivative or primitive. Mark it, antiderivative or primitive, and the entire log x plus c, that is called the integral. That's called integral, and this process of finding out integral is called integration. The process of finding this is called the integration. So what is integrand, what is antiderivative and or primitive, and what is integral? Well, I advise you to learn the formula of integration for everyone. First you ask, suppose you want to have integral 1 by x dx. You ask yourself, what's the derivative of 1 by x? It is minus 1 by x square. And make sure that I am putting that formula, it's not minus 1 by x square as its integral. So integral of 1 by x is log x. Similarly, suppose I ask you integral of log x dx. Immediately in your mind you ask, what's the derivative of log x? It's 1 by x, so don't put 1 by x. Therefore, integral of log x, anybody who can say, that is always x log x minus x plus c. Remember this also. Write this also along with your formula group. Integral log x dx is equal to x log x minus x. See, this can be further simplified, x into logarithm of x minus 1 plus c. This 1 is called the log natural e. Therefore, this is x into logarithm of x minus logarithm of e plus c. Now, you know log a minus log b, that is x into logarithm of x by e plus c. Therefore, the antiderivative of log x is x log x minus x. Similarly, you can say d by dx of derivative, d by dx of x log x minus x, wherever you find, you can simply write log x. Derivative of the antiderivative or integral will be the function itself, the integrand will be. Okay. Now, all the formula we must have a quick run. I don't read all those formula. These are the basic formula of integration. It's directly from differentiation. All the formula that's written 1, 2, 3 like here. Well, so in this formula what you have to do is this. You know, suppose integral of 1 by x is equal to log x, I told you in the previous page, integral of. So you can say that 1 by x, integral of 1 by x dx is log x. Fine. Then, what's the extension of this formula? Before you apply any formula, you must have to make sure that the integral question is exactly similar to your formula. I repeat, before you apply the integration formula of any question, you must have to make sure that the integral question is exactly at par or same as your integration formula. As Shakespeare says, what is in a name? I say, what's in a variable? For example, integral 1 by x dx is equal to log x plus c. integral 1 by t dt is equal to log t plus c. Integral 1 by z dz is equal to log z plus c. The elongated tilde along with dx, that is called the notation of integration. I repeat, elongated tilde and this dx. That's integration with respect to x. So, integral of 1 by x with respect to x is equal to log x. Therefore, integral of 1 by z dz is equal to log z. Integral of 1 by t dt is equal to this. That's what I told you. What's in a name, what's in a variable? Nothing. Alright. So, whatsoever be the question, you have to make sure that before you apply the answer, make sure that your question is exactly same as the formula. Then what extension you have? Look at the formula. Every x may be replaced by first degree polynomial ax plus b. That's the only extension in integration. Indefinite integration, that's the only extension. Every x in the formula, it may be replaced by the first degree polynomial ax plus b. Then you apply the formula, divide the answer by a. A means the coefficient of x. For example, these are the formulae which I have shown you, everything. This I wrote. Similarly, in all the above formulae, x may be replaced by ax plus b with the respective changes. Fine. Again, other formulae I have written. You can just see the formula, almost all the formulae. The basic formulae I have written over here. You can see. I'll come back to the formula later. Well, this explanation is this. Integral dx divided by 2x plus 3, the method of integration. Well, this is a question. Ask yourself. It is exactly similar to which formula? I say formula bar, integral 1 by x dx. Instead of x, what is it? It's ax plus b. That's only permission. So, this x is replaced by 2x plus b. I can apply. Fine. What's the formula? It's logarithm of 2x plus 3 divided by coefficient of x2 plus c. In differentiation, you apply the formula, multiply it by the coefficient of x, and integration, the other way around. So, apply the formula, divide it by coefficient of x. Alright. So, this is equal to 1 by 2 logarithm of 2x plus 3 plus c. So, the antiderivative is this part. Similarly, you know integral of sine of say 3x minus 5 dx. So, it's exactly similar to which one? Integral of sine x. What's integral of sine x in the formula bar? Integral of sine x dx is equal to minus cos x plus c. Well, so this is equal to minus cos of, I do right, 3x minus 5 divided by coefficient of x, that is 3 plus c. Suppose I do ask you what is integral sine of x square, say for example this x square. Now I ask you, suppose this is not there, sine of x square. Can I apply the formula integral of sine x? No. Instead of x there is x square, it's a second degree polynomial where we are not supposed to apply the formula. Unless or otherwise you change your x square into a new variable t. That is called the method of substitution. That's the second phase we have. First of all the formula. Second is this integral of sine of x square. So, if your question, that's the integrand, is not at all similar to the integration formula, you should not apply the formula and get the answer. Should not apply the formula and get the answer. I repeat, should not. Well, if in place of x in the formula what we have, that x is replaced by a first degree polynomial, you are welcome to apply the formula. Right? Well, so plus c. Right. So, this way you should practice this extension of this formula. Now, that is the first one is formula, the second one is extension. That's the second point, extension. Right. Now, number 1, integral of f dash x divided by f of x dx is equal to, tell me, you should also tell along with me, take your pen, paper, solve it along with me. Logarithm of f dash x divided by logarithm of f of x plus c. Number 2, integral f dash x divided by square root of f of x dx. That's equal to 2 root over f of x plus c. Number 3, integral f of x the whole raised to n into f dash x dx. That's equal to f of x the whole raised to n plus 1 divided by n plus 1 plus c, comma, n not equal to minus 1, definitely. So the first and foremost point which you have to remember is this. Whenever your integrand is a quotient, there is a numerator as well as denominator. First check whether the numerator is the derivative of the denominator. First check whether the derivative of the denominator is the numerator, or is the numerator the derivative of denominator. F dash x by fx. Answer, logarithm of this. Example. One example quickly. Integral of cot x dx. Like this. I do write it as cos x divided by sin x. I asked you to check whether the numerator is the derivative of the denominator. So what's the denominator? Sin x. What's the derivative? Cos x. Look at the numerator. The numerator is the derivative of the denominator. The answer is logarithm of sin x plus c. You got it? So whenever we have similarly integral x divided by 1 plus x square dx, what you have to do? The basic method of integration is this. First you observe the question, the integrand, and you identify your difficulty. I say in Malayalam Veshamam. So put your Veshamam is equal to t. The integration process is finished. Now first thing is you have to identify your Veshamam there. X, that's not at all a difficulty. 1 plus x square, oh, that's what it is difficult. I try to substitute 1 plus x square is equal to t. Got my point? So put your Veshamam is equal to t. Now remember one more thing. Don't find many Veshamams. Find only one Veshamam. Understood my point? So that is, if there is one and only one difficulty you have, you can substitute that's equal to t. So x divided by 1 plus x square. My Veshamam is equal to 1 plus x square. I substitute 1 plus x square is equal to t. I am coming back to method of substitution. Fine. Prior to that I told you. This is f dash x divided. What's the derivative of the denominator? 2x. How to make? I give a 2, 1 by 2. I can multiply a constant inside the integral and outside. I can multiply and divide by a variable inside the integral only. Inside the integral sign. I told you elongated tilde. So this is equal to half into logarithm of 1 plus x square plus c. Now these three formulae in one segment you have to keep. Integral f dash x divided by f of x. Oh, numerator is the derivative of the denominator, logarithm of the denominator. Same thing, f dash x divided by root over fx. Remember, numerator is not the derivative of the denominator, but the derivative of the expression inside the square root. That's what f dash x divided by square root of fx, 2 root of fx. Then the generalization of this, that is integral f of x the whole raised to n into f dash x dx, fx the whole raised to n plus 1 by n plus 1 plus c. Right? Now, on to the next type is this. You have integral, I just give this as a set of 3. Set of 3 in 3 sets. So total 9 formulae. 1. Integral 1 by x square plus a square dx. Integral 1 divided by x square minus a square dx. Integral 1 divided by integral or dx divided by s square minus x square dx. Well, those who know the formula must have to write that formula there. So you don't need, in mathematics, you no need of learning anything by heart. You try to understand the point, then it will be very easy to reproduce it. Well, look at this. This question is 1 divided by x square plus a square, means square of the variable plus square of a constant, or a constant simply. 1 by x square minus a square minus a. Somebody may have a thinking that why can't I take a minus sign to this side and apply the same? No problem. It's absolutely right. But there are certain conditions. Whenever I do take 1 by x square minus a square, x is greater than a. A square minus x square, if I do take, a is greater than x. That's the reason. Nothing wrong in taking minus sign and then put your formula. It's nothing wrong. Absolutely, you get the same answer. And one more thing I wanted to tell you, I forgot to tell you there, that there will be no two answers. Answers in the answer of integrals, whether I solve correctly, you solve correctly, we must have to get the same answer. Maybe they may differ by a constant, but the antiderivative will be same, primitive will be same. Okay. Now, what I advise you, you tell me, your one constant is what there then? Your a square. You tell me a constant value, say 1. Substitute over here, 1 by x square plus 1. Yes, 1 by 1 plus x square, I know. It's a tan inverse x. So, this formula is 1 by a tan inverse x by a plus c. If I do put a square is equal to 1, 1 by x square minus 1. Oh, I don't have any formula, but I can split it as x minus 1 into x plus 1. Oh, that can be partial fraction. 1 by first degree minus 1 by first degree. It is 1 by 2a logarithm of x minus a by x plus a plus c. Same thing here, 1 by 2a logarithm of a plus x divided by a minus x. Suppose you take this minus outside, it will become minus of, minus of log a by b is log b by a. You get the same answer. You get the same answer. So you can, whenever you have, if you have any doubt while putting the formula, while solving the question, just apply this method. 1 by x square plus a square. What is a square? A square is a constant. I put what there then? A square is equal to 1. 1 by 1 plus x square. Oh, it is tan inverse. It's not log. Got it? Well, that is the first set here. Okay. Now, the second set will be like this. Put all of them under the root. Integral 1 by square root of x square plus a square dx. Integral 1 by square root of x square minus a square dx. Integral 1 by square root of a square minus x square dx equals. Now, what is the method I told you? Put the constant as 1. 1 by root of x square plus 1. Oh, no idea. 1 by root of x square minus 1. No idea. 1 by root of 1 minus x square. Yes, it's the derivative of sine inverse x. Oh, this answer is sine inverse x by a. The answer is sine inverse x by a. Now, under root is there will be no 1 by a outside. Root is not there is always 1 by a. And the question is 1 by root is there is no 1 by a. This is very simple. Log of x plus that denominator. That is logarithm of x plus root over x square plus a square here plus c. This will be logarithm of x plus root over x square minus a square plus c. Agreed? So, no need of learning it by heart. You can easily. What is sine inverse x by a? What is log of x plus that denominator as it is? Well, we move on to the last set. That's the lengthiest formula perhaps. That is, this root is taken to the numerator. That's the next part. Integral square root of x square plus a square dx. Integral square root of x square minus a square dx. Integral square root of a square minus x square dx. That's equal to. You see? In this session, both the session, we are going to see so many secrets, tricks and top secrets. Well, wait. So, integral root of this. Look at this. What's the formula? Listen me now. The formula, all the three. Remember, x by 2 into the question. Question means integrand. So, all the three x by 2 into the question, that is x square plus a square. x by 2 into the question, that is x square minus a square. X by 2 into root over a square minus x square. So, integral root of x square plus a square dx, integral root of x square minus a square dx, that is integral root of a square. X by 2 into the question. Question means integrand. Well, and many a times I find students are a little bit confused where it is plus a square minus a square. Don't worry, look. Plus whichever constant is there in the question by 2. What's a constant here? Plus a square by 2. Okay. What's a constant here? Minus a square by 2. What's a constant there? Plus a square by 2. No confusion. Where there is any minus sign or plus sign. Don't worry about it. X by 2 into the question plus whichever constant is there, whatsoever be. If it is a square plus a square by 2, minus a square minus by 2. Into, that's the next secret. Formula of 1 by. Look. That is logarithm of formula of 1 by this. Look at this yellow part. That is logarithm of x plus root over x square plus a square plus c. And this is logarithm of x plus root of x square minus a square plus c. And look at this. This will be sine inverse x by a plus c. That's it. So, all the 9 formula, 3 sets, you have to keep this in mind. All right. Now, that's all about the formula. First, now we move on to the next session quickly to the third part. That's called method of substitution. Method of substitution. And to me, I say that it's the most effective method of integration. And where should you apply? There is no limit at all, wherever it is possible. So, method of substitution, that's the most effective method. And what's the idea behind? I told you, you read the question. You can easily observe something unusual in the question. Put that unusual as Veshamam, put Veshamam is equal to T. So, unusual. One example I say, integral of x into sine of x square dx. You read the question. Now, what is usual? Oh, it's very familiar if it is sine x. So, nothing unusual. But the moment you read sine of x square, this is unusual. So, we put what there? Put x square is equal to t. This is called unusual, or I say Veshamam. So, put it is t differentiate. Why do we substitute? In order to differentiate. What sort of differentiation? Differential differentiation. That means derivative of x square is 2x dx. Derivative of y square is 2y dy. Derivative of t square is 2t dt. Derivative of sin t is cos t dt. So, this is 2x dx is equal to dt, because we are going to change the variable x in terms of a new variable. As I told you in the very beginning, what is in a variable? Nothing. But you have to replace every part of the variable. That means this is equal to integral. Let me write this as sine of x square into x dx. X square means t. That is integral sine of t into x dx means from this x dx is what is x dx? 1 by 2 dt. So, it will become 1 by 2 dt. Take this 1 by 2 out, 1 by 2 into integral sine t dt. Look at this. Your question is now reduced to your formula, exactly same as your formula. Integral sine x dx minus cos x plus c. Integral sine t dt minus cos t plus c. So, this is equal to 1 by 2 into minus cos t plus c. Put back your substitution. So, that is equal to minus 1 by 2 into cos of x square plus c. And no doubt, the derivative of your answer must be your integrand when you simplify. So, this is called the method of substitution. Wherever it is possible, you must have to apply it. One more question I will show you, that is substitution. Integral logarithm of x divided by x dx. So usually we don't expect a question in terms of log. So first we say that all right, log x, I told you, whenever you have a quotient as your integrand, we try to substitute, we try to check whether the numerator is a derivative of the denominator. Here the other way around. Look at the numerator. What's the numerator? This is integral logarithm of x into 1 by x dx, the way we write. So the integral derivative of log x is what? 1 by x. So you can put log x is equal to t. Or you can apply this is integral of f of x into f dash x dx. F of x means fx the whole raised to 1. So you can write fx the whole raised to 1 plus 1 by 2. F of x the whole raised to 2 divided by 2 plus c. So this will become logarithm of x whole square by 2 plus c without any substitution or this. Now what is method number 2 I told you? That's the method of substitution. And the unusual thing is equal to t. I say logarithm of x is equal to t. And 1 by x dx is equal to dt. You have your I. It's always a better practice to call every integration form question as I. I is equal to integral. So log x will be t, 1 by x dx is dt, integral of t, t square by 2 plus c. That's equal to logarithm of x the whole square by 2 plus c. Answer. Both. Okay. Now we shall move on to another question, that is integral x into e raised to x square dx. Now you tell me, what is your substitution? What's your Veshamam? What's unusual thing there then? So most of you may say that x square is equal to t, isn't it? No doubt, sure. Both the methods I'll apply. So you say, suppose somebody sees that, all right, this is x square is equal to t, therefore 2x dx is equal to dt. Say this is substitution put. After substitution, you must have to differentiate, don't forget. Why do we substitute? You ask yourself in order to differentiate. So 2x dx or x dx is equal to dt divided by 2. So we write this integral, this is I equal to integral. What is x dx? dt by 2. E raised to t into dt by 2. That is half into integral of e raised to t plus c. So you have half into e raised to x square plus c. Well, now I wanted to show you one more thing. Suppose I see my Veshama is not only x square but e raised to x square. So what I do, method 2, I say e raised to x square is equal to t. Now what differentiate it? E raised to x square into 2x dx is equal to dt, or x into e raised to x square dx is equal to 1 by 2 dt. Now look at your question. Your question is integral x into e raised to x square dx. So that is equal to integral 1 by 2 into dt. That is 1 by 2 into integral dt. That is equal to 1 by 2 into t plus c. And what's your t? Your t is equal to e raised to x square. 1 by 2 into e raised to x square plus c. Your answer. In both the methods, you have the same answer. I told you, you will have the same answer. But remember one thing, there can be a question sometimes in JEE. Out of the two methods means this, what is the effective substitution? Remember this word, effective substitution. What's the effective substitution? If such a question is being asked, the second one is the effective substitution, not the first one. First one is a substitution. Second one is an effective substitution. What is meant by effective substitution? See, effective substitution is that substitution after the substitution we differentiate, and after derivative differentiation, most of the terms of the integrand are replaced by dt. That is called effective substitution. That means after the substitution and differentiation, most of the functions in the integrand are replaced by dt. That is called an effective substitution. Here x dx is only replaced by dt. Here the entire integrand is replaced by dt. So this is called an effective substitution. right? All right. So that is all about the method of substitution. It's up to you. There is no hard and fast rule to say you can. You just observe the question, read the question, identify the unusual part over there. The unusual part. So put that is equal to T, you will be successful. Well, now we move on to the integration of other functions. I just classify them in type 1, type 2 like that. We will have a very quick run. Now, type 1. First means these are all rational functions. Polynomials and rational functions we take. Suppose integral of x square divided by x plus 1 dx. Just with example only I tell. What is this? It's a polynomial divided by another polynomial. So first thing is this, if the degree of the numerator is greater than or equal to degree of the denominator, divide and simplify. So degree of numerator is greater than or equal to degree of denominator. Divide. That's a method. Divide. Now after division, how do you write? Quotient plus remainder by divisor. Divide and write it as in the form quotient plus remainder by divisor. You know how to divide. The degree of numerator is 2, degree of denominator is 1. So we divide x square by x plus 1. You all know how to divide. But I will show you a simple division here. Say, simple manipulation. Okay. So this is equal to integral. What is this? I take x square minus 1 plus 1 divided by x plus 1. Absolutely this is division. X square minus 1 plus 1. Because seeing this, x square minus 1, what are the factors? This is dx. This will become x minus 1 into x plus 1 whole divided by x plus 1 dx. Now we divide, split it. Because a plus b divided by c is equal to a by c plus b by c, fraction property. So we write this is integral x minus 1 into x plus 1 divided by x plus 1 plus 1 divided by x plus 1 dx. Agreed. X plus 1 cancel. Integral x minus 1 plus 1 by x plus 1 dx. This is what I wrote here, quotient plus remainder by divisor. Quotient plus remainder. So what's the integral of x with respect to x? X square by 2 minus integral of a constant into x, that's minus x, plus 1 by first degree, 1 by x, log x, 1 by first degree, log of first degree divided by coefficient of x. Here the coefficient of x is what? 1. So I don't write. So logarithm of 1 plus x plus c. Logarithm of 1 plus x plus c. Okay, that's the answer now. Integral of x square divided by x plus 1. So that is type number 1. Okay, one question I solved from each type. Okay, well, now we move on to the next type. That's type number 2. First is fx by gx. Type 2 is integral 1 divided by ax square plus bx plus c dx. That is 1 by a second degree polynomial. Means 1 by a quadratic polynomial. What's the method? Now let me take the other types also here. Type 3. So that it is easy for you to group together. Integral 1 divided by square root of ax square plus bx plus c dx. That is, this denominator is put under the root. Type 4. Integral, this root is taken up in the numerator. That is root over ax square plus bx plus c dx. Observe your question. If your question is 1 divided by second degree, or if your question is 1 divided by root of second degree, or it is root over second degree, method is the same. Method for all. That is completing the square. Complete the square. Okay, where did you learn? Where have you learned this one? You learned in quadratic equation. You know how to complete. I'll solve one question. Well, question number 1. integral dx divided by x square plus x plus 1. Your 1 divided by, you identified 1 by first degree, I know formula, log of 1 by second degree, it will come into the types there then. So, x square plus x plus 1 is completing the square. See the procedure. In quadratic equation also, I will be touching almost every part of mathematics. First, make the coefficient of x square 1. Fine, it is 1. Then see the coefficient of x. What's the coefficient of x? 1. Take half of it. That is, then you write x plus half that coefficient, the whole square, minus square of this fellow, 1 by 4, plus the constant already there. That's all. It's finished. No need. First I told you, completing the square, make the coefficient. Suppose it is 2x square. You take this 2 outside. So make the coefficient of x square 1. After making, see the coefficient of x. Now take half of it. Had this question been x square minus x plus, suppose, here is one more question I'll say, with the parallel I'll go so that you will be able to understand very easily. Dx divided by x square minus x plus 1. This also, both. Let's move like that. And here I say x square minus x plus 1. Half the coefficient is minus 1 by 2. Then x minus 1 by 2 the whole square, then also minus 1 by 4, because a plus b the whole square as well as a minus b the whole square both have a square plus b square. So only thing is this sign is changing, plus or minus. Minus this 1 by 4 plus 1. A minus b the whole square. Or if you have some difficulty there, then don't worry. Just expand, because your first step should be same as the second step. Whenever you learn mathematics, it's so critical, you have to just verify whether I am writing the previous step only. You need not write anything other than the previous step. You just simplify the previous step. Look, suppose you have some difficulty whether it is right or wrong. Come on, expand this. X square plus 2ab, 2 into half into x, yes, plus x, plus 1 by 4, not there, minus 1 by 4, cancel. And here is what there, 1, that's already written. This is absolutely right. Got it? So same way, a minus b the whole square, x square, okay, it's there. Minus 2ab, yes, minus x is there. Plus 1 by 4, no. Plus 1 by 4 should be cancelled with the minus 1 by 4. That's why there is minus 1 by 4, not plus 1 by 4. Well, this is equal to x, This will be, here I will write, this is equal to x minus 1 by 2 the whole square, 1 minus this will become plus 3 by 4. Okay? And this will be x plus 1 by 2 the whole square plus 3 by 4. Well, this is integral now, dx divided by x plus 1 by 2 the whole square plus root 3 by 2 the whole square. Come on, take your formula strip. 1 upon x square plus a square. X means first degree x. X plus 1 by 2 first degree. The whole square. So this is nothing but integral 1 by x square plus a square. Now what I taught you today, your constant, it is 1. 1 by x square plus 1, or it's tan inverse. So we say 1 by a tan inverse x by a. So this answer will be 1 by a, 2 by root 3. 1 by root 3 by 2. Tan inverse, what's your x? X plus 1 by 2 divided by root 3 by 2 plus c. That is 2 by root 3 tan inverse, simplify, 2x plus 1 by root 3 plus c. Well, now we have done parallel to this question. It is like, what I say, well, parallel this is equal to integral dx divided by x minus 1 by 2 the whole square. There also the same, plus root 3 by 2 the whole square. Same formula, 1 by a, 2 by root 3, tan inverse, and here is a change, x minus 1 by 2 divided by root 3 by 2 plus c. That's equal to 2 by root 3, tan inverse. You simplify 2x minus 1 by root 3 plus c. See, 2 questions I have solved. This is one and this is the second one. 2 questions I have solved. Now, for this other purpose, the second one. The very same question I say integral dx divided by square root of x square plus 2x minus 8. Well, I'll solve first, then I'll tell you a secret. Without solving, you will be able to tell the answer of this. I'll write the answer first. Remember? You just check it. This is a question. I write the answer. This is logarithm of x plus 1 plus root of x square plus 2x minus 8 plus c. I have written the answer. Now we'll simplify. How do we? See, we have x square plus 2x minus 8. Complete the square as I told you. This is x plus 1 the whole square. Okay, minus 1 minus 8. So it is x plus 1 the whole square minus 9 or x plus 1 the whole square minus 3 square. Now we write this is equal to, this integral will be equal to integral dx divided by square root of x plus 1 the whole square minus 3 square. Which formula? Integral dx divided by square root of x square minus a square. That is logarithm of x plus that denominator as it is, x square minus a square plus c. So this is equal to, what is this? Logarithm of x plus 1 plus square root of x plus 1 the whole square minus 3 square plus c. Now, how did you get this x plus 1 the whole square minus 3 square? I got from here. Okay, this I got from the previous step. This I got from the previous step. This I got from the previous step. So, this is equal to logarithm of x plus 1 plus square root of x square plus 2x minus 8 plus c. Look at the answer. Look at the answer. Without solving, I wrote the answer there. It's not a substitution at all. You got the secret? Logarithm of x plus half the coefficient plus that denominator. If it is x square plus ax square plus bx plus c. I repeat, it is ax square plus bx plus c, not a negative. A should be positive, coefficient of x square. For example, suppose I ask you integral dx divided by square root of x square minus 8x plus 25. Now shut your eyes, write your answer. X minus 4 plus root over x square minus 8x plus 25 plus c. Got it? That's our type number 3. 3, 4. What was the type? That was type 3. Now on to type 4, simply one question. Integral, the same question, root over x square plus x minus 1 dx. A different one. Type 4. So same, x square plus x minus 1 equal to. Now do along with me. X plus half the whole square minus 1 by 4 minus 1. X plus half the whole square minus 5 by 4, that is x plus half the whole square minus root 5 by 2 the whole square. X plus half the coefficient 1 by 4 minus 1 by 4 minus 1 minus 5 by 4 and you write. Well, so this is equal to integral square root of x plus 1 by 2 the whole square minus 5 by 4. Even I don't need to write it as root 5 by 2 the whole square. I don't need. Well, what's the thing I told you? I told what there? X by 2 into the question. Okay, fine. So my answer, x by 2, x plus 1 by 2 by 2. Into the question. Question is x plus half the whole square minus 5 by 4. Then what I told you? Plus whichever constant is there. Oh, there is minus 5 by 4. No need of, no worry whether it is plus, minus, nothing to think. Your constant is minus 5 by 4, minus 5 by 4 by 2. The constant by 2. Need not worry about a square, b square, nothing of that sort. Into formula of 1 by, or formula of 1 by means logarithm of x plus 1 by 2 plus root over x plus half the whole square minus 5 by 4 plus c. Your answer, you are through with your answer. Now you count your time, maybe within 10 seconds. So this is to be simplified, or options are there you can write. It will be 2x plus 1 divided by 4 into root over, from where I got this one? I got this one from here, this I got from here. Oh, it's simple. X square plus x minus 1 minus 5 by 8 into logarithm of x plus 1 by 2 plus, this again what there? Your x square plus x minus 1 plus c. Final simplified answer. The three types I clubbed it together. Method is one and the same, but there are three different formulae, and all the three different formulae applied. Well, we move on to the next type, 3, 4. Well, type 5, that is integral px plus q divided by ax square plus bx plus c dx. Type 6, same, integral px plus q divided by square root of ax square plus bx plus c dx. Type 7, integral px plus q into square root of ax square plus bx plus c. One and the same method, and in all the types means what there then? The formula will be different. So, type 5, type 6, type 7, the formula will be what there then? Different. Ready? Well, what's the method? It's a combination of first degree divided by second degree. First degree divided by second degree. So, what do you think? What's the derivative of second degree polynomial? It's first degree. But derivative of a second degree polynomial is first degree. Therefore, you can write your px plus q as a constant a into d by dx of ax square plus bx plus c plus another constant b. A should be obtained, b should be obtained by equating. Then your answer of the first one will become, it is f dash x divided by this. One question I will show you how to solve. Here also f dash x divided by root over fx you get, plus constant by this, that are previous type 2, 3, 4. Ready? So, one question. Integral x plus 3 divided by x square minus x plus 5. Just a minute. X square minus 2x plus 5 dx. Look, x plus 3. Now, method is this. I write x plus 3 is equal to a into derivative of the denominator, that is 2x minus 2. Derivative of x square is 2x, derivative of minus 2x minus 2, derivative of 5 is 0, plus b. Now, what do? We equate the coefficients of x on both sides. Equating coefficients of x, that is 1 is equal to 2a. You understood? 1x, 2ax. So, coefficient will be, therefore, a is equal to 1 by 2. Now, equating constants on both sides. Left side it is 3, it is minus 2a plus b. Okay, that is 3 is equal to minus 2 into 1 by 2 plus b. That means 3 equal to minus 1 plus b, b is equal to 4. You got. So, this will be written as, this is now, x plus 3 is now split as a, 1 by 2 into 2x minus 2 plus b, b means what there, 4, divided by x square minus 2x plus 5 dx. Now, you split this one. Now, you can also verify half into 2x, x, half into minus 2, that will be minus 1. Minus 1 plus 4, 3, correct. Exactly similar to the previous step. I am right. Now, we split this is 1 by 2 out, integral 2x minus 2 divided by x square minus 2x plus 5 dx. Now, make sure that your numerator is the derivative of the denominator. You know the denominator is x square minus 2x plus 5. Its derivative will be 2x minus 2. Yes, absolutely. Then plus 4 into integral. 4 into integral second degree, type number 2, 3, 4. So, your x square minus 2x plus 5 will be written as x minus 1 the whole square minus 1 square plus 5. That is x minus 1 the whole square plus 4. Okay. So this is equal to 1 divided by x minus 1 the whole square plus what there 4 means 2 square dx. Now your answer. This is f dash x by, what is this formula? It is integral f dash x divided by f of x dx. F dash x divided by f of x dx. What's the formula? Logarithm of the denominator. So half into logarithm of x square minus 2x plus 5 plus 4 into this 1 upon x square plus a square, 1 by a, 1 by 2, tan inverse x by a, x minus 1 by 2 plus c. Your answer. You are through with your answer. You can simplify, get the result. 4 and 2 will cancel. There will be 2 tan inverse x minus 1 by 2 plus c. That is the way to solve this type 5, 6, 7. Please try one by one. Okay. Now, try this question itself, put under root and then you have the formula. So, here it is f dash x by fx, here it will become first time will be f dash x by root over fx, that is 2 root. Here means f dash x into root over fx means fx raised to half, fx raised to n plus 1 by n plus 1. Well, that are type number 7. Okay. 5, 6, 7, similar type and that is simplified. Now we move on to next type, that is type number 8. Type 8. Rather, I say it's one of the most important type. It's integral x square plus or minus 1 divided by a x raised to 4 plus b x square plus a. I do right. But usually in your books, in your guides and all there, it will be like x square plus or minus 1 by x raised to 4 plus some ax square plus 1 like that. What are the same? But I have just generalized it. Here the method is divide by x square and put x minus or 1 by x equal to minus or plus 1 by x is equal to t. That's all. Remember that. This is the method of evaluating integral root of tan theta, root of cot theta. One method. So one example I will just show you. Evaluate integral x square plus 1 divided by x raised to 4 plus 1 dx. That's question number 1 out of this type. Right? What's the method I told you? Divide the numerator and divide the numerator and denominator by x square. So, this will be equal to integral 1 plus 1 by x square divided by x square plus 1 by x square. We divide every term by x square. And see, x square 1, x raised to 4, 1. Make sure that this it. Or coefficient of x raised to 4 and this constant should be same. Fine. Now, dx. Now, what do? We put x minus 1 by x is equal to t. Here it is 1 plus 1 by x square, put x minus 1 by x. If it is 1 minus 1 by x square, put x plus 1 by x. That is all. So, differentiating 1 plus 1 by x square of dx is equal to dt. Well, I substituted x minus, the numerator along with what their dx is taken care of. But there is a denominator which is not at all now expressed in terms of t. You know, when you are changing your variable x into t, every x must be changed into t. Well, I put it as x minus 1 by x is equal to t and I got 1 plus 1 by x square dx as dt. That part is taken care of. Whereas there is a denominator which is not at all expressed in terms of t. That's our aim. That's our next thing to be done. So, this is the substitution. From the substitution, what do? Squaring. Why do you square? Because I want to have x square plus 1 by x square. Therefore, x minus 1 by x the whole square equal to t square. What is this? A minus b the whole square. X square plus 1 by x square minus 2ab, 2 into x into 1 by x minus 2 equal to t square. Now, take the one which you need. You need x square plus 1 by x square equal to t square plus 2. Fine. The numerator is now dt. Denominator is t square plus 2. It has been reduced to a simple question now. Integral dt divided by t square plus 2. 2 means root 2 the whole square. Now take your formula table. 1 divided by x square plus a square, or integral 1 divided by t square plus a square, it will become 1 by a, 1 by root 2. Tan inverse x by a means t by root 2 plus c. Integration finished. Put back your t. So this is equal to 1 by root 2 tan inverse. What's your t? Your t is x minus 1 by x divided by root 2 plus c. That's equal to 1 by root 2 tan inverse x square minus 1 by x root 2 plus c. Wonderful answer. This type, that's one of the most important one. Mark it. Do it. Okay. Now we will move on to the next type. Actually that type is not at all mentioned in your syllabus, but still I do complete all. But type number 10, there was a question asked in 2023 JEE Main, type 10, which I am going to tell. You refer that question. That question I will solve along with it. Type number 9. That is integral dx divided by px plus q in the square root of ax square plus bx plus c. Tell me, how do you distinguish this type? Now so far in all the type until this type 7, the first degree polynomial, that is px plus q, that was in the numerator. Now in this type number 9, the first degree polynomial is in the denominator. That's the difference. So in all those types means second degree was sometimes in the numerator, sometimes in the denominator, sometimes with the root. Fine. But whereas first degree polynomial was only in the numerator. Now here in this type, unlike other types, this first degree polynomial is in the denominator. So that's a difference of substitution. The method is this: put your first degree, that is px plus q is equal to 1 by t. That's it. Otherwise we write always first degree is equal to a into derivative of the second degree plus constant. But here the substitution is also different because it's different from the other types. Fine. So px plus q, that is one question I'll solve. Say question: integral I is equal to dx divided by x in the square root of x square plus 2x plus 2. Well, so px plus q. So I say put x is equal to 1 by t. Here my px plus q is nothing but x. X is equal to 1 by t. Therefore your dx is equal to minus 1 by t square dt. Fine. So x is 1 by t, I can substitute. Sometimes if it is x plus 1, your x plus 1 is equal to 1 by t, the x will become 1 by t minus 1, you have to substitute. Fine. This is my substitution differentiation. Well, we do. This is equal to integral. So, integral 1 divided by dx, first of all dx, what is dx? Minus 1 by t square dt. Fine. X means 1 by t, right. Into root over x square means 1 by t the whole square plus 2 into 1 by t plus 2. Right. So this is equal to integral minus 1 by t square dt divided by, look, this is 1 by t square, this is 2 by t, this is 2, LCM is t square, take this 1 by t outside, so this will become 1 by t into 1 by t into root over. This 1 by t square LCM means 1 plus 2t plus 2t square. 1 by t square plus 2 by t plus 2, LCM is t square, so it will become t square, t 1, and this 1 by t square and 1 by t square cancel. And you got this is minus integral dt divided by root over 2t square plus 2t plus 1. Look, this is our type number 3. Well, we have to make the coefficient of t square what there then? 1. So I take this one out. So this is equal to what there? Minus 1 by root 2 integral 2 outside the root. dt divided by t square plus t plus 1 by 2 under the root. I told you I'll write the answer straight away. Minus 1 by root 2 logarithm of t plus 1 by 2 plus root over t square plus t plus 1 by 2 plus c. Or else also you know how to complete the square. That's a method. Well, I told you root of ax square plus bx plus c, where a is positive, simply write that. That is t plus half the coefficient plus this one. Now, you see, what's your answer? Minus 1 by root 2 logarithm of, what's your t? Tell me. Your x is 1 by t. This means your t is equal to 1 by x. I write 1 by x plus 1 by 2 under the root. It is 1 by x square plus 1 by x plus 1 by 2 plus constant of integration c, your final answer. Ready? Now, we move on to the next type, type number 10. Type 10. Okay, that is integral dx divided by ax square plus b into root over cx square plus d. That is 1 divided by second degree without first degree term into root of similar. 1 by second degree into root of second degree, but no first degree term present there then. Okay, here the method is put x is equal to 1 by t. In the previous, first degree full equal to 1 by t. And here x is equal to 1 by t, and we will have to make. This type was asked in 2023 JEE Main. Last year JEE Main. So you just check the question. The question I will write. So integral dx divided by 1 minus x square in the square root of x square plus 1. A similar question like. So what is the method? The method is put x is equal to 1 by t. So dx is differentiate minus 1 by t square dt. Good. The first part, integral dx is minus 1 by t square dt divided by 1 minus 1 by t square in the square root of 1 by t square plus 1. That is integral minus 1 by t square dt. Please simplify. It is t square minus 1 divided by t square in the square root of 1 plus t square divided by t square under the root. This 1 by t square and t square cancel, and this t will go up, minus of t dt divided by, you have a t square minus 1 in the root of 1 plus t square. This is root of t square, it will go up, this t square cancel, minus is there. Again you have an unusual question. What's your Veshamam here? Your Veshamam is equal to root of 1 plus t square. Put your Veshamam is equal to z. One more variable substitution. That is what. So here, what we do is there observing, this is a separate question. Try to solve this question. X dx divided by x square minus 1 into root over x square plus 1. Please do this as a question after this class. Here it is first degree. So what I do is this, put my Veshamam is equal to t. Root of 1 plus t square is equal to say z. Z I say. Or 1 plus t square is equal to z square. Differentiate. 2t dt is equal to 2z dz. Okay? 2 cancel. T dt is this. So it's minus z dz. Okay? Z dz divided by, what's my t square? My t square is z square minus 1. 1 plus t square is z square. So t square is z square minus 1. So it will become z square minus 1 into the entire root is z. This z and z cancelled. That is minus of integral dz divided by z square minus 2. 2 means root 2 the whole square. Now look at your formula. The table of formulae. 1 upon x square minus a square. What's the formula? 1 by 2a log x minus a by x plus a. So it's minus 1 by 2 root 2 logarithm of z minus root 2 by z plus root 2 plus c. Come on. So, minus 1 by 2 root 2 logarithm of, what's your z? Your z is equal to root of, that is, this will become root over 1 plus t square minus root 2 divided by root over 1 plus t square plus root 2 plus c. Is it finished? No, no. What else you have? That means your t is what? What's your t? Your t is 1 by x, final. So that is minus 1 by 2 root 2 logarithm of root of 1 plus 1 by x square minus root 2 by root of 1 plus 1 by x square plus root 2 plus c. That's the final answer there. Okay. Now we will quickly move on to that. That's all about your algebraic, means rational functions, even irrational terms are also there. Then we quickly move on to the next type, that is trigonometry. Then we have integration by parts, and then partial fractions. The entire methods of integration will be covered by this. Fine. We will have quickly the other one. I say type 11. Type 11. Type 10, that is algebra. It's integral p sin x. This is now trigonometry, count trigonometry. It's very important. I have taught you 10 types apart from your substitution. Now this is trigonometry. This trigonometry is very, very important type there then. P sin x plus q cos x divided by a sin x plus b cos x dx. Okay, there is no, mark it, there is no constant in the numerator, there is no constant in the denominator. If there is a constant either in the numerator or in the denominator, you must have to apply another plus c. Now the method, now I ask you one thing. What's the derivative of sin x and cos x? Simply cos x and sin x. There may be minus, doesn't matter. So derivative of sin x and cos x are again cos x and sin x. In all such situation, you write your numerator is equal to a into denominator plus b into derivative of denominator. Can you tell me there is one more function which is very familiar to you, the derivative will be the same? A raised to x and e raised to minus x. So, whenever you have some a e raised to x plus b e raised to minus x divided by some p e raised to x plus q e raised to minus x, apply the same method. So, you can take it as type number 12. But the method is the same. I'll solve a question quickly. Integral sin x dx divided by 2 sin x plus 3 cos x. Now, you keep in mind, first degree in sine and cos divided by first degree in sine and cos, that's all. Anywhere there is a constant, you will have to write a plus c also. So what's the method? Numerator is equal to a into denominator plus b into derivative of the denominator. If there is any constant in the numerator and denominator, you should write a plus c also. A and b I'll calculate. What's the numerator? Your numerator is sin x. A into denominator, that is 2 sin x plus 3 cos x. Okay, plus b into derivative of the denominator, that is 2 cos x minus 3 sin x. Agreed? Now, what next? Equating coefficients of cos x. Do you have cos x in the left? No, 0. Equal to 3a, then plus 2b. Question number 1. Equating coefficients of sin x. Equating coefficients of sin x. How many sin x in the left side? 1. That's equal to 2a, then minus 3b. Question number 2, solve. 2 linear equations you have to solve. Okay? So, then what will be the integral? That's very interesting. Your I will be, your numerator is now changed. A into denominator plus b into d by dx of the denominator whole divided by denominator dx. Now, when you simplify, your answer will be denominator cancelled, integrated a into x plus b into logarithm of the denominator plus constant of integration. That will be your answer. So, once you find your a and b, you can easily find out the answer. Answer is always ax plus b into logarithm of the denominator. So, how do we solve this one? We will multiply the first equation by 3, second equation. 0 equal to 9a plus 6b. And here this will be 2 is equal to 4a minus 6b. We add 2 is equal to 13a. Therefore, your a is equal to 2 by 13. Well, so this will be equal to 2 divided by 13x plus b you have to calculate, that is minus 3. So, minus 3 divided by 13 logarithm of 2 sin x plus 3 cos x plus c. Okay. So, I'll give the secret without solving this way. Anyway, you have to solve. Your b will be equal to minus 3 divided by 13 when you solve. Okay. Well, that is very modern calculation. You can substitute b over here, a over here to calculate your b. Your b will be minus 3 divided by 13. Fine. So, final answer will be 2 by 13x minus 3 by 13 logarithm of 2 sin x plus 3 cos x plus c. So, it's a very, very important one. Now, I just give you a homework of similar type. Integral 9 e raised to x plus 3 e raised to minus x divided by 2 e raised to x minus 5 e raised to minus x dx. In a similar way, you have to solve. Numerator is equal to a into denominator plus b into derivative of the denominator. You can try that also there then. Okay. Now, on to next type number, that is 12, type number 12. Type 12, that is integral dx divided by a sin square x plus b cos square x plus c sin x into cos x plus d. Dx by a sin square x plus b cos square x. What is this now? The previous trigonometry is what there then? 1 divided by, first degree sin and cos by first degree sin and cos. Now, this type is 1 divided by second degree in sin and cos. Second degree, a constant. Second degree, only second degree in sin and cos and a constant. Method is very simple. Method. Divide by cos square x or sin square x, but I do apply this cos square x. One example, integral dx divided by 1 plus sin square x dx. You see, numerator is a constant, fine. Denominator, second degree in sin and cos, good, fine. Method, divide by cos square x or even sin square x. So, this will become integral 1 divided by cos square x, because numerator is 1. 1 divided by cos square x plus sin square x divided by cos square x, okay, dx. This is integral sec square x dx, 1 by cos square x. This is also sec square, but I write 1 plus tan square x plus tan square x. 1 by sec square x, that is 1 by cos square x, sec square x. Sec square x is 1 plus tan square x, whereas in the numerator it is tan square x. Now what next? Put your Veshamo is equal to t. I say put your Veshamo. What's your Veshamo here? That is tan x. Put tan x is equal to t. Therefore, sec square x dx is equal to dt. Well, effective substitution. Substitute now. That is dt divided by 1 plus 2t square. Take this 2 out. 1 by 2 into, or you can write root 2t the whole square, not anything wrong. Anyway, 1 by 2 I do take, dt divided by 1 by 2 plus t square. 1 by 2 I write 1 by root 2 the whole square. So, 1 by 2 into 1 upon a square plus x square or x square plus a square, 1 by a tan inverse x by a. 1 by a means 1 by root 2. Tan inverse x by a, t divided by 1 by root 2 plus c. This root will go, you have 1 by root 2 tan inverse, okay, this root 2 into t. What's your t? Root 2 tan x plus c. Final answer. Ready? Now, we move on to type number 13. Type number 13. Type 13. See, usually everywhere it is first degree by first degree, then 1 by first degree, then 1 by second degree. But I do teach in a different way. First degree divided by first degree, then 1 by second degree, then I am coming back to 1 by first degree. That is integral dx divided by a sin x plus b cos x plus c. So first degree by first degree, that's our type number 11. 1 by second degree, that is you divide by cos square x or sin square x. 1 by first degree. Usually when you read any one of the textbook, you can see that put t is equal to tan x by 2. But I advise you not necessary. You write your sin x as 2 sin x by 2 into cos x by 2. You write your cos x as cos square x by 2 minus sin square x by 2. So you reduce this first degree into, this is reduced to your previous type number what there, 12. So this first degree I have changed into second degree. Second degree you know the method. You need not learn any more method. What's the method? Divide by cos square x by 2, not cos square x by 2. Apply the same method. So same thing. One example. Integral dx divided by, say, 1 plus sin x plus cos x. So distinguish this type. 1 divided by first degree. 1 divided by first degree. Correct. It's not first degree by first degree. It's not 1 by second degree. It's 1 by first degree. Well, I do right. This is equal integral. So you observe your integrand. 1 and cos x, wherever you find, you group them together. So integral dx divided by 1 plus cos x plus sin x. What's the formula for 1 plus cos x? 1 plus cos x is very simple, 2 cos square x by 2. 1 plus cos x. So this is dx divided by 2 cos square x by 2 plus 2 sin x by 2 into cos x by 2. Fine. I have changed that into what there, then second degree. Now what do? You divide by cos square x by 2. Let's divide this by cos square x by 2. The numerator will be sec square x by 2 by, now what is that? 2. This will become 2 plus what there then? 2 tan x by 2. Divide every term by cos square x by 2. So how simple, look at. Now let me take this 2 and give it to the numerator. So this is equal to 1 by 2 sec square x by 2. You will understand why I do so. By 1 plus tan x by 2. What's the derivative of the denominator? Derivative of 1, 0. Derivative of tan x by 2, sec square x by 2 into 1 by 2. Now could you understand why I took this 2 to the numerator? I have taken this 2, I took it to the numerator. So it is f dash x by f of x formula. Integral f dash x by f of x straight. Dx. Within no time you got your answer, logarithm of 1 plus tan x by 2 plus c. Right. So we move on to the next one, that is the next type and the most important type, type number 14. Type 14. That is integral sin x plus or minus cos x whole divided by function of sin x into cos x. This whole divided by not necessary, it can be here also. The method is put sin x plus or minus, your question is sin x plus or minus cos x dx. So substitution is sin x minus or plus cos x is equal to t. Look at your type number 8 of this similar, exactly similar. So this is another most important type in trigonometry. So integral sin x minus or plus cos x t. I'll definitely solve a question in the next session. All right, as this time is running out. So this is sin x plus or, if the numerator is sin x plus cos x, put sin x minus cos x equal to t and then you square. If the numerator is sin x minus cos x, put this one. This is the most important one. I will definitely solve a question in the next session. The question session we will solve. Okay. Well, so the next one is the fourth section of this is integration by parts. Integration by parts. Integration by parts everybody knows. So integral of first function into second function is equal to first function into integral of the second function minus integral of derivative of the first function into integral of the second function. Now remember one thing, when you observe this type of formula, you observe it very closely. you can easily see that only the integral of the second function is taken on the right. So even if you do not know the elementary integral of the first function, doesn't matter. So it indirectly says you one thing. Integral of x into y is integral of y into x. Any function can be first, any function can be second because the product is commutative. Therefore, you select that function as the second whose integral is known to you. Now, it should clearly come into your mind. I repeat, out of the two functions to be integrated, the function whose integral is known to you must be kept as your second function. Simple. So, whenever I do teach this integration by parts, I always say that we Indians are always late, isn't it? Are you? No. So, we Indians are always late. We take it as I late. I for inverse trigonometric function. L for logarithmic. You all know it. I know. A algebraic function. T trigonometric function. E exponential function. That's the order. Who should be first? Who should be second? Right? So, who should be first? Who should be second? That will be it. So, like this, just one question I solved. Integral x raised to n log x dx. You must know this answer also. This is x raised to n plus 1 divided by n plus 1 into log x minus x raised to n plus 1 divided by n plus 1 the whole square plus c. I late because I do not know the integral of log x. But I told you today in the beginning, the integral of log x is x log x minus x. I know. But still, this is I is equal to integral log x into x raised to n dx. First log x into integral of the second x raised to n plus 1 by n plus 1 minus integral derivative of the first 1 by x into integral of the second x raised to n plus 1 by n plus 1 dx. 1x and x cancel. You get x raised to n plus 1 divided by n plus 1 into log x minus integral. 1 by n plus 1 is a constant. 1 by n plus 1 is a constant. So, I take out x and x raised to n plus 1 cancel, x raised to n dx. You know again, this is x raised to n plus 1 divided by n plus 1 into log x minus 1 by n plus 1 into integral of x raised to n plus 1 by n plus 1 plus c. Okay. So, this is x raised to n plus 1 divided by n plus 1 into log x minus x raised to n plus 1 divided by n plus 1 the whole square plus c. Okay. Now, in this integration of x raised to n log x, you must remember another formula. That is integral e raised to x into f of x plus f dash x dx. That is e raised to x into f of x plus c. I always say that whenever you have an e raised to x in your integrand, you first check e raised to x into fx plus f dash x. One example, integral e raised to x into sin x plus cos x dx. So, the moment example 1, sin x is your f of x, then f dash x is equal to what there? Cos x. Immediately, we write e raised to x into sin x plus c. So, integral of e raised to x into fx plus f dash x, that is e raised to x into sin x plus c. Now, I give a secret. Always remember this also along with it. Suppose integral of e raised to f of x, not x, don't expect every time x. So, e raised to f of x into f dash x into g of x plus g dash x. Right, shut your eyes and write e raised to f of x into g of x. This is a tip I wanted to give you today. Integral e raised to f of x into f dash x into g of x plus g dash x. E raised to fx, then f dash x into another function. Answer, e raised to fx into gx plus c. It will help you a lot. We will come back to that in the next session. Okay. That is. Now, with this also a third formula, remember, integral x into f dash x plus f of x. This is also another very good formula, that is x into f of x plus c. So whenever you have an x in the numerator, x into a function plus another function. So x into f dash x plus f of x into f of x plus c. These two you have to remember. Similarly, integral e raised to ax into sine bx and all you have. Now on to the last part, that's a partial fraction. Partial fractions. Well, I do classify the partial fractions into three types. Number one, if you have a factor that is 1 by x minus a, I say linear factor, this is called linear, then write that as a by x minus a. Sometimes you have repeated linear factor, that is R, L, F, I say, 1 by x minus a the whole square, repeated linear factor. You split this as a by x minus a plus b divided by x minus a the whole square. Then next is non-linear factor. That means you cannot further factorize. 1 by x square plus a square, or quadratic expressions where discriminant is what, they are less than 0. You write it as ax plus b divided by x square plus a square. Fine. Therefore, one example, say simply integral x square plus 1 divided by x into x minus 1 into x plus 1, suppose. This is the question. Now, point is this, when will you apply partial fraction? That's the question. With this, we will wind it up. Well, when will you apply partial fraction? Remember, when the degree of the denominator is more than 2. When the degree of the denominator is more than 2, you must apply partial fraction. That's all. Now, look, a partial fraction to be applied only for proper rational functions. Proper means degree of the numerator is smaller. First type I told you, degree is greater or equal, divide. Now this degree is 2, degree is this. So this is to be written as a divided by x plus b divided by x minus 1 plus c divided by x plus 1 dx. Okay. So this will become, answer is a into logarithm of x plus b into logarithm of x minus 1 plus c into logarithm of x plus 1 plus k. That is, your a will be, a is this one, your a will be minus 1. So it is become minus logarithm of x. Okay, your b will be, b means logarithm, b will be 1 logarithm of x minus, please verify that, you solve it, because this is a by, you cross multiply, you know the method, later I will tell you the secret, then this is, this will become, that's also plus 1 logarithm of x plus 1 plus k. That will be your answer. Your a will be minus 1, your b will be 1, your c will be 1. So your answer is minus log x plus log of x minus 1 plus log of x plus 1 plus k. And you know how to do this partial fraction, cross multiply, simplify. Okay. Oh, with this, we conclude our first session. I have gone through the entire methods of integration, indefinite integration. All right? Okay. We wind up this session now. I look forward to you in the next session. That's a problem solving session. I'll be discussing all the questions of 2023 JEE Main, as well as some more questions. Okay. Stay with us. Thank you.